My name is Josh Knox. I'm a senior technical marketing architect for Carbon Black, and we are going to do part 2 of container image scanning in Carbon Black Container. And this time around, we are going to focus on the cbctl tool that allows us to scan images from the command line. In part 1, we went over cluster or container images. If you click down here on container images, we went over this dashboard and looked at all these tabs. And so if you need to get an overview, go back to part 1 and watch that, and you can see an overview of the container image dashboard and all the different information that you can get after the scans have been put into the Carbon Black cloud. But today, we're going to go to Inventory, Kubernetes, Clusters, and then we're going to figure out how to configure the cbctl CLI tool. So we're going to start here by clicking on this CLI config tab right here. And we are going to add a CLI. You can see, you can see the one I did when I was getting ready. So let's hit add CLI. And we will do, since I already have video demo, we're going to do video demo 2. And we're going to define a build step here, and we're going to call it the demo build step. And this is video demo. That's good enough. And so you're going to define the CLI. Let's talk about that for a second. So the reason we're defining this CLI is this CLI is going to get API keys. And so it's going to be a specific cbctl tool. You could give this to a developer, and then you could, if they leave, you could revoke this API key. The reason that we have this set up is so for ease of creation, so that you don't have to go in and remember the specific type of API permissions for scanning. You just use this add CLI, and this is going to take you through creating an API key specific with the permissions needed to do the scanning, and that's really nice. So let's go ahead and hit next. And now we're going to generate API key, and we're going to call this one demo 2. See if it likes that. And you can see there, it says that that key was created successfully. All right, so let's go to next. And now we get our instructions here for configuring the CLI client. Now, in my case, I am going to install it on an Ubuntu machine. So I've got an Ubuntu machine ready, already up here in the cloud. And we are going to install on it. So you have to find your version. If you click down here for downloading, we've got the CLI client for Linux is what we want. Now I am going to right click on this guy because I don't want to download it here, and I'm going to copy link address. We're going to pull my terminal back over, and I'm going to do wget and paste that link in, and there we go. And we're going to do that, and here it is right here. Here's the cbctl tool. Now, what I am going to do at this point is I am going to go ahead and run the built-in Linux install command. So let me copy that in here. Handy command if you didn't know about it. We're going to run a sudo because we need to have elevated privileges to do this. We're going to install cbctl, and we're going to install it in the user local bin cbctl. And now if I run it, cbctl, it works, and it works as expected. So I've got it installed now on this machine. So let's go back over here to Carbon Black Cloud. Now, right now it won't work. If we tried to, for instance, do cbctl image scan Ubuntu, it's not going to work. And the reason is you see here, it says failed to establish connection to the Carbon Black Cloud. Please check your config. Well, we haven't even created a config. So let's go ahead and do that according to the instructions here. So it says copy this command into your terminal and run it. So we're going to, and just to look at it here, it's going to make a directory in our home directory that is going to be a .cbctl directory. And then we are going to do a do a here doc. That's what this is. This is right here, and it's going. This has all the bits in it that we need. The cbctl default. We've got the API ID, the API key, the org key, and the SAS URL. So let's copy this, and we will run it in our terminal. Paste anyway. We're gonna run it. All right, there we go. Now, if I do this again, we can see that now there is a .cbctl folder that was created. And if we take a look in it, we see there's the file. And if we cat the file, cbctl, it's dot, that's why. There we go. And there it is. There's your API key. There's everything we need to run our scans. All right. One of the other things that you need to know is that you don't have to have this file this way. You can have this set up as environmental variables. I'll get into that more in part 3, because when I run this in a pipeline with GitLab runners, I put these the API ID and the key in as secrets in my repository, and then they are created as environmental variables when I do my my pipelines. But that'll be for part 3. You'll have to come back for that. So let's go ahead and try out now cbctl, and we're going to use, if we do the help here, we can see what we have, and we want image. So here's image right here. So now let's do cbctl image, and we'll do help again for fun. And we'll see here that we have print image packages, scan the image, and validate. We're just going to care about scan and validate today. So let's do cbctl image scan, and we'll do something easy like Ubuntu. All right, so that was fast because the container's already on this machine. It already has a scan ready for it. So scan in progress. It fetched the image because this scan's already been done and the hash has not changed. So it printed out the results of the last hash or the last scan. And we see that there are some medium vulnerabilities here. There's some low vulnerabilities. No files with malware or bad reputation were found. And I love this next part. Detailed report can be found here. So if I hold down Control and click on this guy, my Chrome opens up directly to this page, and I get the latest scan on this Ubuntu. So there we go. And like we saw in part 1, now we have all the same things we had before. We have layers, packages, any suspicious files, scan log, which is a lot because I've been practicing for this, etc. So that's really cool. All right, so that is the scan. The scan is that easy. And if you are running this in a pipeline or just running it locally, like you can see, you get the results come out here. If for some reason you would need these results in a different format, there are flags that you can use. You can see the output string. You can change the output to a different format if you need to. There's some other possible things that you could use there that you can look at in that help. All right, so the next thing that we want to look at is the image validate. So when we created this cbctl particular CLI, remember, we had to, and we're going to go ahead and hit done here on this because it's done. We had put a build step in. And the reason that you have that is that you can associate that build step with a policy. So let's go to enforce, and let's go to Kate's policies, and we will click over here in hardening policies, and we will go to dev container builds. This is the policy I have here, dev container builds. And we'll see here that the scope is all container images, and it has dev container build. And now we're going to hit next. And we can see that this policy is set up to stop known malware and vulnerabilities with fixes. So if there is known malware found in the image when it scans, it will block it. If it finds vulnerabilities with fixes, it will also stop and tell us about those. And right now it is enabled. So we see here that this policy has been enabled. There it is right there, enabled. So let's go back to the command line again. And now we're going to do a image validate. There we go. And let's first do something easy like Nginx. And now we have to add, we're telling it to validate, but we have to tell it what to validate. So now we're going to put in here build step. And I have created a build step called dev that I've associated with that policy. And now when I run that, we can see that the scan is in progress, and it again, I've already run this scan before, so it doesn't actually scan again because the hash has not changed. It's the same image. And so it says that Nginx finished successfully with no violations. And this means that it ended with an exit code that allowed it to exit successfully. Now, on the other hand, let's go ahead and I'm going to actually scan first so you can see this. We're going to scan xmrig. Now, this is a crypto miner that's on Docker Hub. And we scan it and we see that when we scan the xmrig, this is actually a really old image. I think when I looked at it, this image is almost 4 years old now. So there are a lot of critical vulnerabilities in this image. There are high vulnerabilities in this image. And down here at the bottom, we actually find the xmrig file, which has a reputation as known malware. So now, and again, same thing, if we clicked on this link, we would be able to see it in the Carbon Black console. Now we're going to switch and we're going to do that image validate command, cbctl image validate, and we're going to do xmrig with that build step of dev, which is tied to that policy, that build step dev policy that we made. And so now, let's make my window just a little bigger and we'll run that again just so we can see that a little prettier. Okay, so we ran it again, and again, it did not actually run the scan real time because the image has not changed, so it's going to bypass that and just tell us what it found out. And we find out that there are vulnerabilities with fixes. Remember, that's what our policy was. If there were vulnerabilities with fixes, to show us that, and if there was known malware, to show us that. And because there was known malware and because there were vulnerabilities with fixes, we see that the validate finished with violations. Now this is great because if you're running this in a pipeline or you're running this somewhere else, you can run the validate command and your pipeline will fail if it violates the policy. Now, if you're not worried about that, you can just run the scan and you can look over those scan results yourself. But if you are trying to actively stop containers that have fixes in them that you could run or that have malware, etc., you're going to want to use this cbctl image validate tool. And remember, it doesn't matter where we run this from. You could run this from your developer machine. In part 3, we'll look at running this inside a pipeline where we can use it as a tool to stop the pipeline if something bad is in the image and we don't want it to move forward. So there you have it, the cbctl tool, so you can do your own scanning. Remember, it is under inventory, Kubernetes, clusters, and then you're going to click here on CLI config, and you're going to add a CLI. Or if you already have those API keys maybe stored somewhere and you just need the binary again, you can click on download CLI and you can just download the binary itself. All right, well, that's it. Thank you for your time.